Good morning, everybody. How many times have you been in a conference in the past few years without hearing either AI or machine learning? Right? Even if it's a conference about food or shoes, right? It's so cool today to talk about artificial intelligence and to talk about machine learning. Actually, these are excellent examples of the buzzwords that our industry invents. I have been probably attending in the past 2 years at least 100 different talks. I bet you there was not a single one where these words were not present. It is so cool to talk about this. Now, I've been in the field for probably at least 20 years. At least these are the years that I can remember of. And people often ask me, hey, Ciprian, what do you think about the future of this field? Where is it heading? What's going to happen in 2 years, in 5 years, in 10 years? And I usually like to answer using the words of classics. When folks ask me about the future of machine learning, I like to use the words of a classic, Master Yoda. And he said, it's a famous quote, right? Clouded this boy's future is. And I think this perfectly defines the future of machine learning. Because on one hand, if you take it like literally, the future of machine learning depends on the public cloud. The amount of resources is just insane these days. The amount of resources that you can get to run your machine learning workloads. And it's not like it used to be 20 years ago when you needed like millions of dollars invested into super powerful supercomputers. Actually, today, it's 1 or 2 clicks away, this immense power. But on the other side, it is a clouded future because, and I'm a guy who loves history. Everybody who loves history knows that humankind is a weird species. Every single time we had immense power in our hands, we almost killed ourselves with it. Think about that crazy guy who one day at the beginning of the 20th century took a piece of paper, a pencil, and imagined himself in an elevator free falling. It was a couple of years later that we had the specialized theory of relativity. It was a couple of decades later that we had the first atomic bomb. It was another 2 decades until we almost wiped out ourselves with a missile crisis in Cuba. So I believe machine learning, although sometimes people say this is a little bit too much, but I believe it's at least the same kind of power that we are starting to have in our hands. So every single time I'm asked to talk about the future of machine learning, I always say there is a bright side to it and there's a dark side to it. Ignoring either of them is probably a fatal mistake. And let me start with the bright side. Another question that I always get is, give me one example where you think machine learning is making the most powerful impact, the most profound changes. And I never need to think about it because I always say healthcare research. Healthcare research is an area that in the past 15 years has made enormous advancements. Most of them thanks to machine learning algorithm. This is just a simple example, is one of the probably thousands of examples that we can give in this particular area. And of course, Machine learning is having an impact not only in this particular field. Machine learning is having an impact on the way we purchase things, right? Think about your experience signing into any kind of e-commerce portal, starting from the largest one like Amazon.com to the smallest company, right? You sign in and then you get something like, hey, Cyprian, isn't it that you signed in today because you wanted to buy this? And I'm like, hell no. 30 seconds later, it's like, actually, I think I need this, right? Then think about the way we interact with our homes. It's not so far the moment when our homes will adapt to our mood, will adapt to our actions, will adapt to the patterns of our behavior. In fact, there are lots of setups today that already can do that. And then there is autonomous driving, right? It's like sometimes when I like to think about the future, I'm freaking out about the world where we have autonomous cars exclusively on the road. Like, dude, gee, that will be interesting, right? But we're heading there. We already do have autonomous cars. And then, of course, there is the problem of search. The benign search, the thing that we all take for granted, is probably one of the fields where machine learning has made a significant impact. There is a set of studies that says that we as a species, we double the amount of data that we generate every 18 months. Mark my words, we double it. Meaning that the growth of the amount of data that we have on this planet is exponential. The difficulty of searching through that data is at least 2 orders of magnitude higher than that. Yet as of today, you can find almost any piece of information you're looking for using different search engines, different platforms that are baked from your browser to your device to your car to whatever. And then finally, there's the issue of security. Starting from biometrics, starting from face recognition, voice recognition, retina identification, and so forth, and so forth, and so forth. Actually, the largest organizations that study what's happening in IT, they all are in a consensus saying that this is not stopping. Actually, this is accelerating. This is going to penetrate every single aspect of our lives. And let me just show you very quickly something that I have started a few minutes ago, just to, yeah, that's an example of machine learning. Not a very smart one, but machine learning, nevertheless. So here's a simple example of some experiments that I have started to run on Microsoft Azure Machine Learning Service. It's not really the details that matter. It's the compute resource that I'm using. I'm using a small training cluster, a CPU training cluster that currently has 25 nodes. And I'm running workloads. I'm currently training about 400 different machine learning models that do kind of a very cool thing. They attempt to create the Uber model to predict the list of top 100 in YouTube charts for the next week. So, believe it or not, this is a thing that somebody needs. So, here's an example of those models that are being trained. And as you can see, I have different results for them, and some of them are already trained, some of them are running, and so forth. Now, the interesting thing is, when I create such a cluster, the highest size of a VM that I can use on Windows Azure, Microsoft Azure, is the standard ND40S-V2, which is kind of a stupid name. The interesting thing, though, is that that particular VM has 8 V100 Volta NVIDIA GPU cards in it. And if you're wondering what the heck is a Volta GPU card, it's something like this. And take a look on the right side, it says number of CUDA cores, 5,120. So 8 Volta GPUs will have roughly around 40,000 GPU cores. And if I create a cluster of 25 such VMs, I have 1 million GPU cores available for my machine learning workloads. So I believe that kind of makes a point, and obviously every other public cloud provider is capable of providing these types of resources. So no wonder that machine learning is kind of skyrocketing. And then there is this. When this becomes a thing, we will need to unlearn almost everything we know about classical computing, this being a quantum computer. And this will be able to accelerate certain workloads that today would take hundreds of years down to minutes. And then machine learning will be completely reinvented. I mean, isn't that great, right? Not so fast. Yay! Thank you, right? Not so fast. Not everything is bright and shiny in La La Land. Here's a guy that is considered to be one of the 3 parents of deep learning, Joshua. He is one of the guys that has probably had a fundamental contribution to the development of machine learning in the past probably 2 decades. And mark his words, the dangers of abuse in this particular little thing called machine learning are very real. In fact, they are so real that Joshua, together with a bunch of other high-profile professionals and researchers in the world of machine learning, have created what is known today as the Montreal Declaration for Responsible AI. And that declaration contains a dozen of points about what is the definition of responsible AI and how should we approach responsible AI. And that's fine, and that's great. The reason I like that declaration is it is a chilling inventory of all the ways in which machine learning can go wrong in this world. So, the previous talk was about having time, right? If you have time, I encourage you to read that declaration, at least the intro of the declaration, to see that chilling list. And then, obviously, all the large players, like Microsoft, for example, they have significant kind of focus on what responsible AI means. Now, with all the shiny things that I've been kind of enumerating at the beginning of the talk, let's now move a little bit to the dark side and see what are the threats. Let's see a little bit which are these ways in which machine learning can go wrong. What are the biggest threats to the future of machine learning? And I will start with the obvious one. There is a terrible shortage of skills to evaluate, to build machine learning models, to deploy machine learning models, actually to understand machine learning models. IDC has a study that says roughly around 2025, there will be a shortage of over 200,000 data scientists in North America only. If you extrapolate that to the entire world, probably the shortage will be somewhere between 300,000 and 400,000 data scientists. The reality is, the universities of the world today are not capable of producing enough people with high enough skills to master this particular area. And that is something we all see in, for example, an increase in the number of challenged machine learning projects. And when I say challenged, I refer either challenged as features, as budget, or as time. I don't want to be a hypocrite. I make a lot of money because of these projects, right? Because I'm a consultant and I have enough experience to save most of them. But overall, the future of the field is kind of under threat because of this. There's no easy solution to this. I often hear people saying, yeah, we will just need to increase the capacity of our universities. Really? You think it's that easy? The obvious answer is not. Let me move on a little bit to things that are even more difficult. Let's think about equality. What happens with machine learning, it is so easy to create inequality. And I give you a stupid example, but a very, very good one to picture this. Think about a machine learning model that is trained for, let's say, a credit scoring problem for banks. And that machine learning model is trained with data that corresponds to people living in urban areas. And then think about the results that credit scoring machine learning algorithm would yield when you feed data related to people from rural areas. Right? Well, today nobody does this anymore, but it's an obvious example on how an apparently pure mathematical model can generate serious inequality in the world. I said security had huge benefits from machine learning, yet there is another side of the coin there, right? Attackers, folks who want to find security breaches, who want to attack, they also benefit from the advancements in machine learning. And I kind of remember 20 years ago the discussion about hackers. And back then, a hacker was usually something more or less like a script kiddie who downloaded some script from the internet and was poking with different ports and servers. And we were thinking, boy, this is a threat. Well, today, you're not fighting script kiddies anymore. You are fighting well-funded organizations, sometimes backed by rogue governments, who have virtually limitless resources in terms of doing almost anything. And the same principles that apply to biometrics, face recognition, speech recognition, text-to-speech, and so forth, can and are used by these types of organizations. And the obvious question is, how do you fight against this? And again, there's no easy answer to that. Let me move on a little bit. So, here's another one. This is what we call unintentional bias. One of the things that kind of separates machine learning from other fields of computer science is that it is much, much easier to shoot yourself in the foot without even knowing it. I've seen many cases where folks were like, look, Ciprian, we have this trained machine learning model and we're so proud of it. It's so good. We are using it in production. And then when you start analyzing the behavior of that model, you realize the model is biased. Is either biased, like as I presented the example of, say, urban versus rural, but it could be gender biased. It could be biased towards any kind of aspect that has not been properly analyzed from a statistical point of view when the machine learning model was trained. And the one phenomenon that makes this exponentially worse is the wannabe data scientist. This is something that I see a lot these days. Folks who have gone through 1 or 2 online courses, who know a little bit of statistics. I'm a data scientist, right? And given the shortage that I've talked about, in many cases, they actually get to do real projects. And they actually get to produce real trained machine learning models that sometimes end up in production. And in many cases, this is why I call it unintentional. In many cases, they are not even aware of the bias that they have introduced in their models. How do we fight that? Well, again, no easy answer. But of course, we can be very careful when choosing who are we working with in machine learning projects. So, I talked about the autonomous car, right? Everybody's so hyped. If you go into Silicon Valley, probably every second startup there has something to do with autonomous driving. And obviously, if you think about it, one of the core tasks in autonomous driving is recognizing properly road signs. Yet, there are documented ways in which you can take 5 to 10 rectangular stickers, place them on a road sign, and it will completely mess up with the recognition of that road sign for most of the machine learning models. There is another famous example where you see 2 images of a panda bear. When you look at them, they are identical for your human eyes. If you apply machine learning pattern recognition on them, the first one will be properly recognized as a panda. The second one will be classified as a gibbon, which is a species of monkey. Why the difference? Because somebody was smart enough to apply some RGB noise to the first photo in a way that it makes it invisible for the human eye, but it completely changes the patterns that a machine learning algorithm detects. And the reason why we have that is because no matter what you hear in many conferences, machine learning is not working as the human brain, at least not yet. These types of intentional attacks are called today adversarial attacks. Think about the world where we have only autonomous cars on the road. And think about folks having fun sticking stickers to road signs. And then instead of turn to the right, you get turn to the left in the machine learning model. And fortunately, here we have an entire area of scientific research that is trying to fight by improving the machine learning algorithms, that is trying to fight this. And then we get serious. A few days ago, news broke that China has started to sell autonomous killer drones to whoever has enough money to buy them. Here's an ethical question. Is it right for a machine to decide based on no matter how smart machine learning models to kill or not to kill a human being? This is a profoundly difficult question. The obvious answer is no, but reality starts to be very, very, very different. The broader question is, to what extent should we allow application of machine learning and, in a broader sense, application of artificial intelligence to militarized gear, to weapons that have the clear capability of killing human beings. And then there is this. We've talked about unintentional bias. But what about intentional bias? What about me being super smart, super villain, and poisoning your data sets? Poisoning, of course, in a statistical way, right? And poisoning them in a way that will, in a very, very subtle way, change the behavior of your machine learning models. I bet you, in 95% of the cases, you or your data science team won't even notice that. This is the kind of modern type of attack that worries me a lot. It's not the one where I steal your password and I sell it on the dark web, right? Yeah, that's bad, but that's the kind of thing that eventually you learn about. This kind of thing is the kind of thing you probably will never learn about. And it really, really makes it like super, super weird. And then, what if I'm even worse than that, and I want to impersonate you? Today, we only need about 20 to 30 minutes of recording of the voice of any of you to train a machine learning model that then will be able, using text-to-speech, to make you say anything. Even worse than that, it's doable with video as well. And I bet you deep fakes will be one of the huge threats to some of the fundamental beliefs of the human race, among which probably among the most important ones being democracy itself. And we're already seeing that. It's not something that it's somewhere in the future. Unfortunately, we do already see that. And then, this is not the highest threat, but the second highest threat, is data itself. I love when I hear speakers at various conferences, how they say, this is a deep learning network, it has 500 hidden layers and 2 million nodes. And this is capable of recognizing or of understanding or of classifying anything. Yeah, that is almost true. But what's also true, there is not a single person on the planet understanding why that deep learning network has that capability. Deep learning networks are, by their nature, highly recursive systems. And computers are systems that are inducing rounding errors. There is no CPU or GPU yet that is capable of handling an infinite number of decimals for a floating value. So those minute roundings, together with the complexity of such a structure, actually result in us being unable to explain why that happened. We have some clues why, but there is no scientific and proven method to explain that. And finally, the worst threat to machine learning is hype, especially marketing hype. You go to conferences and you go to business talks, and expectations are set like this. And then you go, you talk to those customers, you start thinking and you start exploring real projects, and then you need to lower the expectations like this. And they're like, yeah, but we went to that conference and we saw that guy from Microsoft, Google, Facebook, Apple, IBM, blah, 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 saying that anything can be done with machine learning and with AI. Yeah, you know, but the reality of your data, the reality of what you have here does not allow you to do that. And even worse, what happens? Sometimes you find technical people saying, yes, we can do it. They start the project ends up being a challenged project. Now try to put yourself in the shoes of a customer. You burn $1 million once. You burn another $1 million twice. Would you start a machine learning project a third time? Probably not. And this overhype, this over-expectation regarding machine learning might very well lead us to something that has a name. It is called an AI winter. It is a period of time where people kind of cool down tremendously on machine learning. The reason why it has a name is because it has already happened in the history of AI and machine learning. Not once, but twice. Look out on the web and search for AI winters, and you will see what I'm talking about. And this, my friends, is the most important threat to machine learning, setting the wrong expectations. So, what I have tried to picture today is not necessarily a prediction about the future of machine learning per se, but I wanted to go through some of the bright sides and some of the dark sides. Focusing only on the bright sides and picturing this bright image of machine learning solving all our problems as a human race is the worst thing we can do. Focusing only on the negative sides, on the dark sides, is also not the best way to do. Finding a balance and always keeping in the back of our heads the question, is this thing that I'm doing an ethical thing? Is this thing that I'm doing something that can be used in positive purposes, or with positive purposes, or with negative purposes, is very, very important. Finally, I would say that machine learning, and to a higher extent AI, are probably one of the most powerful and important assets that humankind has ever had. The big challenge is avoiding shooting ourselves in the foot with them. With that, I thank you very much, and I wish you a great Codecamp conference here in Bucharest. Thank you.